Okay, we are gonna go to our next practice problem, but we are going to do one of the problems that we see here. We're going to be doing problem 629, which pertains to this truck and trailer example. Okay, now you're going to be doing 630 for your homework for your application problem. So I thought it would be kind of nice to get a setup, go through the process so that then you can duplicate that process with different numbers for your actual application problem. So we're kind of getting you set up nicely for that. So let's look at the problem statement here and then jump into doing the problem. So it says here that a building contractor uses his utility truck to bring his tools and materials to various sites. The trailer's loaded weight, capital L, and that's going to be listed down here in the data, acts as if concentrated at its center of gravity E. So the load itself is going to be concentrated here going down, and it's going to be L, 13.5 kilonewtons going down. That'll be the weight of the trailer. The pickup truck used to tow this trailer has a total weight W, that's down here, 28.5 kilonewtons going down at B. Okay. And it says here, ball hitch D between the trailer and the truck acts like a pin connection. Okay. If the truck and trailer are at rest, so they're just sitting here right now, not moving, and have the given dimensions and weights, they want us to determine the force, called the tongue weight, that the trailer exerts on the ball hitch at D. Okay. And then also find the force exerted by the ground on each of the two tires, A, C, and F. Okay. So even though this doesn't look like a frame, all right, it's acting like a frame. And when we draw the free body diagram, I'll kind of show you why it's similar and it acts like a frame. So we can solve this like a frame. And our internal pin is going to be that ball hitch. Okay. Now remember, this is not moving down the road. This is just sitting static, right where it's at in equilibrium. Okay. So let's start by drawing our free body diagram and then adding in the information and the dimensions that we see here. Okay. And we're gonna use the diagram that we see here as well. So free body diagram first of the whole together frame. And yes, it is simulating a frame, but it is our truck and our trailer. So we're going to put our convention in place first. Okay. And what we're going to do is we're going to draw our member to represent the truck. Now I'm going to make this look like just a frame, like a link. Okay. So this is going to be our truck. And then right here is going to be point D. Okay. And then this is going to be our trailer. Be a little bit shorter. Okay. There. Right. And then I'm going to just put a little dotted lines here to show that they overlap. Okay. So this is one member. This is our trailer on the right-hand side. And then our truck is over here. In the front here is going to be point A. Okay. And then B is going to be right about here. And then C up here. C is next. And then D is here. All right. And then E. And then our back wheel, which is F. Okay. So kind of like two separate members here connected with an internal pin. At D. Okay. So now let's put our external loads, and those are going to be the weights of the truck and the weight of the trailer. So it told us that the weight of the truck is 28.5 kilonewtons going down at point D. 28.5 kilonewtons. And then the weight of the trailer is 13.5 kilonewtons going down at E. Okay. Now, let's look back over here so we kind of get the lay of the land. So A, C, and F are the tires or the wheels, right? So those are considered roller supports. So that means they're each going to have one force supporting perpendicular to the surface that they're riding on, which is horizontal. Okay, so that means at A, there's going to be an AY, and I'm going to assume that it's going up. So it's going to be our AY. Let me zoom out a little bit. So I'm going to have AY. Then C is a roller support, so that's going to be CY. This is my internal pin, so I'm going to skip over that. This is my weight, and then F is also a roller support. So this is going to be an FY. Okay. So any questions so far about what we're doing? And here, remember, we don't show on the pull together, all together frame, truck and trailer. These are internal forces, so we don't show those on this together. And then now we just have distances in between. So the distances that we have in between are all identified here. Okay, so distance A is 1.17 meters. So I'm just going to put it right in between here, 1.17 meters. The distance between B and C is distance B, so that's going to be 2.24 meters. Then between C and D, I'm just going to draw a little line here. This is 1.42 meters. Between D and E is 2.59 meters. And then between E and F is 0.61 meters. Okay. So now we've got 1, 2, 3 unknown forces, right? Now, as we look here, we're just going to kind of think ahead. So if we sum our forces in the Y direction here with the full together frame, notice that we have too many unknowns. We have 3 unknowns. We're not going to be able to solve it. And then if I think, oh, let's do a moment, if I put my finger on A, I still have 2 unknowns at C and at F. Do you see that? And I don't have any X's that I can use. So honestly, with this all together, I cannot solve for the reactions at the supports. I just can't. There's too many unknowns. So that just means that I can't do it here. So I'm going to then move to the individual members. So I'm going to look at the truck by itself and the trailer by itself, and I'm going to see if I can solve there. I'm going to start with the trailer, just because if I look at the truck side here, I'm going to have 2 unknowns plus the unknowns at D. So I kind of can see out that's going to be too many. But if I look at the trailer, I just have 1 unknown and the unknowns at D. So I have a better shot at doing that one. So I'm going to start with looking at the trailer first. Okay. So I'm going to leave this blank here because I couldn't calculate my supports, my reactions to my supports. So now I'm going to break it into the separate members to solve for the internal reactions. So I'm going to look first at the trailer. Okay. The trailer. So here, I'm just going to draw my horizontal line representing the trailer. The left-hand side here is going to be D. Okay, so this is my pin at D. This side is going to be F. And I know that there is a roller that is there. So it's going to be my FY. It's one of those external reactions. And then I know that at E, I have the 13.5 kilonewtons going down. I know this is 0.61 meters, and I know that this is 2.59 meters. Okay, so these are my external loads, the weight and the reaction at that wheel. My internal pin, remember this is my internal pin, this is going to have an X and a Y reaction. I didn't put my arrowheads on yet, okay? Now, as I look here, which way do we want to put the dy? So we want to put it up or down? And again, it doesn't matter. We just got to assume a direction. So don't try to overthink it. But do I want to go up or down with my dy here? Yeah, I'm good with up, 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 up. Yep, we're saying up. Looks good. Let's do up. And what about my x here? Do I want to go left or right? Left. Right. Doesn't, I'm going to tell you, it doesn't matter. There's no other x forces, right? So it is going to equal 0, but we need to just identify it. I'm going to put it in the positive direction. So we're just going to put it going to the right. Okay. So now that we have the internal x and y on that pin identified, and we have these guys, now we're ready to use our equations of equilibrium to solve for our unknown values. So why don't we start with that x right away? Excuse me, I got a tickle in my throat. Sum of the forces in the x equals 0, dx is equal to 0. There we go. Okay. We do need to show it and we need to calculate it because 0 is a value. Okay. Now, let's think about our unknowns here. Now, if we sum our forces in the y here, we're going to have two unknowns. Not that it's a bad idea, but might as well decide, okay, I want to take one of those out of the equation here. So I'm going to sum my moments, right? And what am I going to sum my moments around to help me out? D, sure. We're gonna sum our moments around D. So sum my moment around D is equal to 0. Go ahead and sum your moments around D to solve for Fy, okay? So you should end up with 10.927 kilonewtons for Fy. And if you haven't gotten there quite yet, give you a chance. Everybody got that? Right. So now that we have Fy, we can go ahead and sum our forces in the y to get dy, right? So go ahead and do that. Sum your forces in your y to solve for dy. And I'll do it down here. It's not right tonight. So you should end up with 2.573 kilonewtons. It was a positive value, so assuming a direction of up was correct for dy on the trailer. Okay. Everybody get that same value? Any questions on that one? Okay. So that takes care of we knowing all of our values on our trailer. So now what we want to do is dy is the internal pin connecting this to the truck. So now what we're going to do is we're going to look at the truck and we're going to use this direction of dy, which is the connector. We're going to use the same magnitude but opposite direction on the hitch on the truck. So on the next page here, we're going to draw the free body diagram of the truck. Okay. And I'm just going to draw it as a line. D is at the end here. All right. D is at the end. C is going to be our back wheels. B is our center of gravity where we're going to put the weight of the truck. And then A is our front wheels. A and B, between A and B is 1.17 meters. Between B and C is 2.24 meters. And between C and D is 1.42 meters. And then we know at A, we had AY going up. B, we had the weight going down, which was 28.5 kilonewtons. C is our wheels supporting going up. And D, okay? D, we're going to go back to our trailer. And on the trailer, dy was going up 2.573 kilonewtons. So it's an internal pin. It's going to go down at D, same magnitude, and it's going to be 2.573 newtons. This is also the tongue weight, okay? This is the tongue weight. And it makes sense that it's going down because that's the force that it is seeing from the trailer, okay? So here, this is actually the truck pushing up and supporting it, but this is going down. Oh, kilonewtons, thank you. I saw that. Kilonewtons going down. But now this is going to be what the truck sees going down. It feels it going down. That's the tongue weight, okay, that it sees. So now we only have two unknowns in the y direction here. So we can solve for those two unknowns. So using our equations of equilibrium, where do we want to start? Sum our moment around A. I like it, Chris, because that's going to take AY out and CY will be our only unknown, right? So yeah, let's go ahead and sum our moments around A equal to 0. Put our finger on A, pull in the direction of B, C, and D, and then we'll solve for our unknown CY. So go ahead and write your equation and solve for CY. Sorry, Kenneth, do you have to add in the dx? Oh, the dx was 0. Yep, since it was 0 on the last one, I mean, you could put it in here and say that dx is equal to 0, but because it's sitting and it isn't moving, forward or backward, it's not seeing that x direction load. So we don't have to add it in for for the calculations here on the truck because it's 0. Does that make sense? Yeah, okay. Good question. I should have mentioned, that you wouldn't have to put that in because we already determined it was 0. So you should get CY equal to 13.423 kilonewtons. Okay, it is a positive value, so that means that we assumed the correct direction. So this is going to be 13.423 kilonewtons going up. Okay. So that means we have one more to solve for, right? AY. So it makes sense that we would use some of the forces in the Y equals 0 to solve for AY. So let's go ahead and solve for AY. So we've got AY minus 28.5 kilonewtons plus our CY 13.423 kilonewtons minus 2.573 kilonewtons is equal to 0. So we can add these together, put them on the other side. You should get AY equal to 7.65 kilonewtons. 17.65 kilonewtons. There we go. Now, to check everything, all right, what we want to do is we want to go back to our original diagram that we had for our put together truck and trailer, okay? And then we're going to pull these back in and make sure that everything equals 0. So I'm going to go back to my first page, which was page 5 in our guided notes, okay? And I'm going to put in the values that we've been getting here. So on my truck, I just calculated AY. This was 17.65 kilonewtons, right? My CY, 13.423 kilonewtons. My DY remains internal, remember? So when this is together, I don't put this in the free body diagram, okay? But I am going to go back to my FY, which was on my trailer, that was 10.927 kilonewtons. Okay, now these all remain in their same direction. We only change the direction of internal pins. Okay, so if I sum my forces in the Y direction, I'm hoping this all comes out to 0. So I've got a positive 17.65 kilonewtons. I've got a negative 28.5 kilonewtons. I've got a positive 13.423 kilonewtons, negative 13.5 kilonewtons, and I've got a positive 10.927 kilonewtons equal to 0. Should have started over to the left a little bit. Let me know, does it end up being 0 equals 0? I don't know. What do you guys get? Does everything cancel out here to be 0 equals 0? I hope so. Yes, Nia says yes, he got it. Yep, you got to plug it all in our calculator. Good. Anybody else get that same value? 0 equals 0. Just want to get it confirmed. Yes, thank you, Deborah. So we're going to put a little smiley face because that means that we did all our work correctly. Okay, if we come back here and we end up and we don't have 0 is equal to 0, then that means somewhere along the line we didn't get what we needed to. Okay, so let me stop the recording for this problem here.